Alright, hi class, and welcome to this video. Here we're going to try to sketch this graph of this rational function. So, should be pretty good. You can see it's rational because there's a polynomial in the numerator and a polynomial also in the denominator. So, go ahead and write that down on your page and let's see what we can do. The next screen is going to start talking about the exact things you want to look at. So whenever you're sketching, look at all these things. First, factor the numerator and the denominator. Then look at each of these individual points. You might want to pause the video at this point and just copy those things down, because in the rest of the video we're going to look through all of those points, and at the end we should be able to sketch the function. So first thing, factor the numerator. Not a problem, you guys have done this many times. First thing we got to do, I guess, is check out and see what are the possible zeros of this numerator function. Well, let's see, 1, -1, half, and -1/2. It's always best to just try an easy one. X equals 1 is often very easy, so I tried that one first, and whoa, look, it worked. Hallelujah. Okay, great. So we now have this factor, x minus 1. Well, now that we've got the 1 factor, we're off to the races. Next step, just do some division, and eventually you come up with all the factors of the numerator, and ultimately that's our goal. We wanted to factor the numerator. Hey, that 0 makes me feel good. Okay. So here is the complete factored numerator. We've got that trinomial left to continue to factor, and we've got to get that done in green. We've got the final fully factored numerator. There's the answer. Great. Next up, denominator. Okay, let's go ahead and do that one. So here's a trinomial. Same idea, just gonna easily decompose that one down. If you're having trouble with that, this is a skill you gotta have figured out. So maybe we'll go back to another video or look at another example. You've got to be able to get that factoring right every time. Anyways, now we've got the complete factored form of this function. There's 2 binomials in the denominator and 3 binomials in the numerator. And wait a second, look at these. These 2 are common. So they can be canceled, and what we're left with is this factored form here. Now, those 2 factors that got canceled, that tells you straight away, as soon as you see that happening, you've got a hole. There's a hole somewhere. Where is the hole? It's in the 0 of that factor. Okay, so I need to make a little more space there. So the x, when x equals 1/2, there is a hole in this function. Okay, so no problem. But now that we've got the x value, what's the y coordinate of the hole? Well, we can just plug in the x coordinate into the original function after you've already canceled that factor. And here we can find the y coordinate. So we know the exact ordered pair of where the hole is. And there it is. Rewind that if you want to watch that one again so you can see how that worked. Okay, well, let's put that on the grid. Okay, we know where the hole is. Let's indicate that. There's our table of values, x and y. And so let's draw a little open circle to indicate that, yeah, there's a hole in the function right about there at x equals 1/2, y equals -3/14. Okay, next up, look at some more points on this graph. We need to know y-intercepts. That's not too bad. Just plug in 0 for x. And what you end up finding is the y-coordinate is -1/3. So we have our y-intercept. We can put that on the graph too. You can see slowly but surely we're starting to build this up, and we're starting to get more points on the graph. Okay, there it is, 0, -1/3. Oh, erase and do that a little bit more neatly. I guess with a smaller pen. There we go. Okay, so we've got a couple little details here. Let's go on to x-intercepts. X-intercepts are nice because they're just going to give us more points on the graph. So once your function is factored, no problem. You have the x-intercepts already. 1, 0, -1, 0. Let's get those down as well. Okay, we're starting to take shape. We can almost start to see what this graph might look like, at least in that small area. Okay, what's next on our list? Vertical asymptotes. Another easy one, because once it's factored, you can already see where the vertical asymptote is. X equals -3. Great, let's draw that on and use your ruler to make a nice straight line. And the thing about this line, it's not part of the function, it's an asymptote. So that's why I'm going to change it from a solid line into a dashed line. And what that indicates is it's not actually the function, it's just something the function gets close to. Okay, so that's vertical asymptotes. Next up, horizontal. Let's see what we got here. There's the degree of the numerator, which is 2. There's the degree of the denominator, which is 1. So right away we know, since the degree of the numerator is more than the degree of the denominator, that already tells us there's no horizontal asymptotes. Okay, next up, what about slant asymptotes? Well, we know that those only exist if the degree of the numerator is exactly 1 more than the degree of the denominator. So in this case, yes, we do have a slant asymptote. So where is it? Well, what we're going to have to do is divide the numerator by the denominator. So I just quickly expanded the numerator, and now we're going to divide it. Here's the division. Synthetic is usually the fastest, so I'm going to use synthetic division right here. And here you go, dividing the numerator by the denominator. Don't forget that 0 in the numerator function. Okay, and here we go. We have the final form, which looks like this. Now that remainder portion doesn't matter at all. That's not part of the function. The slant asymptote is just the x minus 3. That's because when x gets really large, 8 over a really large number is basically just 0. So that's why the slant asymptote, we can ignore that remainder portion. And so there's our slant asymptote. Let's graph it. We have the y-intercept, we have the slope, we can graph this straight line. Keeping in mind again that this is also not part of the function, it's actually an asymptote, which means the function gets close to it, but not quite at it. So that's why I'm going to go ahead and change that from a solid line into a dashed line. Okay. Well, what's next on our list of things to do? Let's see, we've got all the asymptotes, we've got the y-intercepts, the x-intercepts, vertical, horizontal, slant asymptotes. Last thing is to put a few more dots in there so we can actually see what the function looks like. So you want to have a point at each portion of the graph. So we're going to want one up over there at x equals -2. We've already got one in between the two x-intercepts. Let's get another one on the right side of that x-intercept at x equals 1. There it is at 2. And I'll let you guys go ahead and figure out what those y-coordinates are. I just put the numbers down. And it looks something like that, the function approaching those asymptotes. Okay, now look at this though. When x equals -4, the function's way down at y equals -15. So unfortunately our graph is too small. So here's a bigger one. And there's that part we already looked at. If we punch that point in, -4, -15, there it is. And if we graph it, we've got the graph.